Welcome to the continuation of our lesson on creating the Tic-Tac-Toe game from Chapter 13 for CPI 111. At this point, we need to create some scripts that will allow the computer to fight back and play against the human player. In the chapter in our textbook, it starts off by creating a basic version of moves that the computer can make. I'm going to reorganize things a little bit and start off by creating the more clever computer component that's listed in the book. So in creating the computer moves, you can think about what type of moves that you as a human would make playing tic-tac-toe, what your strategy would be. And so, as it mentions in the book, if you are able to make a move that will allow you to win, that's the one that you're going to go for. If there is no move that will allow you to win, the next best thing to do would be to check if your player is about to win in their next move and block them. If neither of those things is possible, but the center position in the tic-tac-toe field is open, you should grab that one. And if none of those things is possible, then just pick a spot on the board and place a piece there. So we're going to set up some scripts to make those things happen for our computer component. So let's start off by creating a script called FindWin. This is going to be our first attempt by the computer is going to look to see if it can win by placing a piece in some position. So I'll create a script. It's called scr_find_win. I'll just paste in our code here. So this is going to start to look awfully familiar. So what we're doing here is we are again marching through our field array, and we're checking to see if there is an empty spot in each of the cells in our field, starting from the top left cell and then working our way across and then down. And then if there is an empty spot, we're going to stick in one of the computer pieces into that slot. Then what we'll do, once we've got that in the array, we'll run our check computer win function that we put together in the previous part of this lesson, and then check if the computer wins with the position in the place that the piece in the position that we've just placed it. Then we're going to return true, which means the computer can win by placing the piece in that spot. And so we'll do that, and then the whole screen will get refreshed, and we'll see that the computer has won, and then we'll show the score and do all of that stuff. However, if in each of the spots that the computer is going to test, if it can't win, then it will replace the computer piece back with the 0, so it'll leave that slot in the array empty, and then it will try the next spot. If it makes it all the way through checking every spot in the play field and none of them works, none of them will allow the computer to win, then it will return false. That's what's happening here. So we set things up to allow the computer to check whether it can win, and then made it so that if none of the positions it tests work, then it's going to return false. So what do we want to have happen if none of those works? Well, going back to our original strategy idea, the next thing to test is whether or not the computer can block the player from winning. So let's create a script to do that. And we'll call this one script find lose. And if you think about how this works, you will realize that the script is going to function almost exactly the same way as the FindWin script. First, we were checking to see whether the computer could win by placing a computer piece in each of the possible positions in the board, and then checking for a win. So here we're doing the same thing, but now what we're doing is in any slot in our field array that's empty, we're going to put in a player piece and then check to see if the piece in that position would cause the player to win. What if it finds one? What if it finds a position that would allow the player to win? Well, in that case, it's going to stick in the computer piece into that spot. So its move will be effectively to block the human from being able to win in that spot. Now, if you think about how this works, it's only going to block the first spot it comes upon, right? So the way it's set up, it's going to be starting at the upper left-hand corner of the field, going across, and then down row by row. And so it's not quite as intelligent as it could be. It's just grabbing whichever one it finds first and then blocking that position. And then if it makes it all the way through without finding any place where it can block the player, then it returns false, and so it will be set to go on to the next strategy. So that's what's happening in our check lose or find lose script. So if we continue down our list of strategies, if the computer can't win and it can't block the player anywhere, the next thing it's going to do is to check whether the center spot in the field is open, and if so, it'll stick a piece in there. So let's create the script for that. Call it find center. And we're going to create this script so that our computer isn't too good, basically. We're going to make it so that it's only going to place a piece in that center spot, both if it's open and only half the time. So what we're saying is randomly, assuming the computer can't win on its own and it can't block the human, then half the time, if that center position is open, it'll put its own piece there. And that's what we're doing here. So we've got a random check, which is going to return either 0 or 1, and if it's less than 1, meaning, so if we get 0 and that position is empty, then we'll put in a computer piece and we'll return true. Otherwise, we'll return false. So we're marching all the way down all of our possible moves on the part of the computer. Now we finally reached the part where what is it going to do if it just can't achieve anything, basically? How are we going to have the computer move? Well, as a final strategy, we'll just have it move randomly and stick a piece in somewhere that's empty on the play field. So let's create that script now. And we're going to call it find random. And it's not going to look too surprising. We're going to start and look for a empty spot in our field, and we're going to choose to insert in a random position. So we're grabbing, we set local variable I and j. These are going to be our positions in the field array. Then we're going to choose either 0, 1, or 2 as the position going across and going down. And then we'll check to see whether that random position in the field is empty. And if so, then we'll put a computer piece into that spot, and then we'll exit out of the whole loop. So now we have our scripts prepared to allow the computer to try out different strategies, one after the other, after the other, after the other, before just choosing a random spot. But we haven't yet created a script that will actually allow the computer to make that move. So we need to do that next. And for the script I'm going to put in here, I'm going to move all the way to the very last part of Chapter 13, where we're going to make the computer adaptive. And what this means is that we're going to have the computer make its choices of the moves to try on any given turn dependent on how well or poorly the human is doing in the tic-tac-toe game. And the idea will be that if the human player is really good and is winning more games than the computer, then the computer will become a little bit smarter and it will try more strategies. On the other hand, if the human's not doing so hot and the computer is winning more games, then we'll make the computer a little bit less smart and it will try fewer moves. And if the human's really doing lousy, then the computer will be really dumb and it will just choose a move at random. So let me show you what that script looks like. We'll call it find move. So here we're declaring a local variable called level. And to populate that variable, what we're going to do is we're going to take the current player score and add 1 to it, and divide it by the computer score and add 1 to that. And we're adding 1 to make sure we never have a situation where we try to divide by 0, which would cause the game to crash and the computer to be unhappy. So think about what this number is going to be when we divide the player score by the computer score. The larger the number is, the better the player is doing, right? And the lower the number is, the worse the player is doing. So with that in mind, we look down at these series of if statements, and we use these if statements to decide which moves the computer is going to try. So I'm going to come all the way down to the bottom here. You see, if we come to the bottom, we've got this random move function being called. So what's going to happen is the very first if statement says, if the level is greater than 0.5, then the computer will try to find a winning position. But what if it's not? See, we're going up here, 0.8, 1.2. What if it's below 0.5? What if the player's really doing lousy? Well, in that case, the computer will just pick a random move. But if the player's doing a little bit better, so we're above 0.5, then the computer will try out the winning move, and then it will exit. But what if the player is doing even better than that, and it doesn't find a winning move? Then it will also try to find the opponent's losing position and then block it. And if the player is even doing better than that, the computer will also then look to see whether the center position is empty, and then it will make that move. So our increasingly smart computer based upon how well the player is doing. So now we have all of our computer player scripts in place. The last thing that we need to do is to modify our field click script so that we can call the functions that will allow the computer player to actually make its moves. So opening back up our field click script from earlier, all I need to do is uncomment the function calls that we had inserted in there earlier. So what we're going to do here is we're going to call our check end script, and then if we're not having an end, then we'll continue down and we'll let the computer try to find its move, and then after that we'll again check to see if we've hit the end of the game. So with all of that in play, we should be able now to have the player move, and then immediately the computer will do its move. And the computer wisely blocks me. So I go over here to block the computer, come down here. We get a draw, we hear a sound, it updates the number of draws and gives us a message box. And we can move our way around, and here the computer wins, plays a sound, and so on. So that's it. Your assignment is to complete this game from beginning to end in Chapter 13. lots of typing involved, but it's an excellent practice for using GML, and it will give you a sense of what you can actually accomplish using GML, things that you can do much more efficiently and more powerfully than you can using the drag and drop system. So get in there and get to it, have fun creating the Tic-Tac-Toe game, and good luck.